Hello and welcome back to another episode of One Wingspan Above, where we discuss anything to do with ground effect. Today we're going to talk about the Regent Viceroy. The Viceroy is the first model Seaglider that Regent is producing. They've already made a quarter scale model that is flying or test flying at the moment, and they have just started making their first full scale prototype. This is a little model we made to make it easier to show you guys what it looks like. Obviously there's no hydrofoil, there's no engines on this one, but it shows you the overall shape of the Regent Viceroy. We tried reaching out to Billy Thalheimer from Regent and Shay Aslam from Ocean Flyer, who's bringing in the Seagliders to New Zealand where we are. But unfortunately, they didn't respond to our emails. So all the information in this episode, we got off the websites, the Twitter feeds, everything public. And we kind of tried to make our own assumptions and conclusions from there. So here we go. So let's start with some general information about the Viceroy. The Viceroy is a 12-seater aircraft plus two crew. It exclusively travels over water. And it does it in one of three states. It can float, it can foil, or it can fly in ground effect. And Regent mentioned that the full-scale prototypes will begin human flights in 2024, which is for us next year. Before we get into details, we'd love to compare the Viceroy to other existing skim machines, but there are not many examples of ready-built ones available. There are some Russian and Chinese types, but they are mainly prototypes and not a lot of information is available of them. So we'll compare the Viceroy with the Airfish 8, which at the moment is the closest comparable ground effect plane. Even though the Airfish can only carry 8 passengers plus 2 crew, it seems to be a vehicle that has the most flown hours and has got the most information available. We will also compare the Viceroy to a comparable airplane as well, in particular a Pilatus PC-12, and this is a highly reliable passenger airplane that's been flying since 1991. It is capable of carrying 9 passengers plus 2 crew, and it's along the same lines of the Airfish for easy comparison. We will also compare the Viceroy with a 12-passenger taxi boat, the Tejas 1, for completeness. The main dimension of the Viceroy, so the wingspan of the Viceroy is about 19.8 meters wide. The wingspan of the Airfish 8 is 15 meters, so it's a little bit smaller, and the Pilatus has got a wingspan of 16.28 meters. Needless to say, our boat doesn't actually have any wings. Since the vehicles are different sizes, the best comparison figure would be wing loading. The wing loading specifies how much load in kilograms is carried by each square meter of wing. Regent gives the Viceroy wing loading as 264 kilograms per square meter, which is massive. The Pilatus wing loading, for comparison, is about 183 kilograms per square meter. And the estimated wing loading for an Airfish is about 52.8 kilograms per square meter. This gives the Viceroy by far the highest wing loading of the three, even though its wing has the highest aspect ratio, or in other words, has the skinniest wing. This means that the wing would have to be stronger so it wouldn't break. The distributed motors on the wing would spread out that load over the whole wing, which might help. Generally, a high wing load indicates a longer takeoff, but since the Viceroy gets up on its foils first before flying, this might be negated. An advantage of the higher wing loading would be a more stable flight, as it would not bounce around as much. Now let's compare some numbers that might be quite useful. The Viceroy is noted to cruise at 300 kilometers per hour and has a range of 300 kilometers. The Pilatus airplane cruises at almost 2 times faster at 537 kilometers per hour. And the range is about 10 times more at 3,417 kilometers. The Airfish machine cruises slower at about 167 kilometers per hour, but has almost twice the range at 556 kilometers. The water taxi goes at a leisurely 28 kilometers per hour and reaches about 196 kilometers. When compared to an airplane, for some reason the skim machine range and speed are pretty pathetic. Despite its high wing loading and low ground effect drag, the Seaglider is still trailing behind the Pilatus with regards to speed and range. Of course, it blows the water taxi out of the water. It gets interesting though when we compare fuel efficiency. There are no numbers available for the Viceroy per se, but the Pilatus has a listed fuel usage of 250 litres per hour, and the Airfish is noted to use about 70 litres per hour. If we recalculate this for litres per kilometre, we get for the Pilatus a 0.46 litres per kilometre, and the Airfish a 0.41 litres per kilometre. The Taishu's water taxi is 0.64 litres per kilometre. This oddly puts the plane and the skim machine almost at similar levels, with the Airfish only slightly better economics despite skim machines being known to have less drag due to ground effect, and the water taxi consumes the most by far. The Viceroy is powered by electricity, so it will be hard to directly compare the Seaglider with these numbers. Regent also doesn't list any numbers at all with regards to energy usage, apart from the 120 kilowatt rating of the motors. But it's assumed that the cost per kilometre will be well under that of the Airfish, as the Airfish used a V8 500 horsepower combustion engine, which would translate to about 370 kilowatts. Fun fact, a Nissan minivan can take about 15 people and would have a similar range to the Viceroy. It would burn just 0.08 litres per kilometre, so that's a nice number to go for. I wouldn't recommend driving the minivan at 300 kilometers per hour though. Since we're comparing, the Seagliders fall in between the water taxi and the plane as a mode of transport. So what is it? The skim machine is actually certified under the IMO, the International Maritime Organization, and is a maritime vessel. The IMO states that these craft are supported in their main operational mode solely by aerodynamic forces which enable them to operate at low altitude above the sea surface, but out of direct contact with that surface. The IMO and the ICAO, the International Civil Aviation Organization, have agreed that any craft capable of flying outside the influence of ground effects at an altitude of more than 150 meters, typically referred to as Type C, should be in such a flight be subject to the rules and regulations of an ICAO. In other words, it's an airplane. Other craft, including those with limited flyover capability, should be covered only by maritime regulations. In the case of ground effects, IMO recognizes three types of skim machine: A, B, and C. Type A, a craft which is certified for operation only in ground effects. Within prescribed operational limitations, the structure and or the equipment of such a craft should exclude any technical possibility to exceed the flight altitude over the maximum vertical extent of ground effect. Type B, a craft which is certified for main operation in ground effects and to temporarily increase its altitude outside ground effects to a limited height, but not exceeding 150 meters above the surface, in case of emergency and for overcoming obstacles. Type C, a craft which is certified for the same operation as Type B and also for limited operation at altitude exceeding 150 meters above the surface in case of emergency and for overcoming obstacles. So what type of craft would the Viceroy be certified as? With a wingspan of 19 meters, it would generally be operating inside a vertical envelope, which is below 150 meters, and the quarter scale model operates at the top end of the ground effect envelope. The wing is slender, and even though the wing loading is quite high, the design looks like there would be no reason that it wouldn't be able to exceed this height and escape ground effect, since it's essentially an aircraft based on its geometry. As we covered in previous videos, the flight above the surface for the Seagliders is fully computer controlled and stabilized. As described in multiple instances by Regent, the captain of the ship would have no direct way to increase height above the surface. This would slot the Viceroy into certification as a Type A skim machine. However, if the control system was ever to be disturbed by, say, a rogue wave, air disturbance, or a computer malfunction, the craft would easily gain height above the vertical extent limited by the Type A classification. This would enter the Type B or even the Type C classification depending on height gained. Once it jumps out of this region, the craft would have no problem flying outside of ground effect. It doesn't seem to be dependent on it. And perhaps Regent will opt to give the captain the controls to do a temporary height increase to allow the Viceroy to jump obstacles it cannot evade in time by banking. This would then mean it would be automatically classified as Type B, at least. Well, it turns out that recently the Ocean Flyer company, the company that are bringing the Seagliders into New Zealand, stated in a Zoom meeting that in fact the Seaglider will be certified as a Type B.
We're in the Type B, which means that it flies in ground effect most of the time, but it has sufficient excess thrust to climb if it needs to.
This has not been publicly confirmed by Regent as far as we know, but we're assuming that Ocean Flyer has all the correct information. Currently, Regent are stating, as per Billy Thalheimer's interview on Vertical Space podcast, that the US Coast Guard are Regent's certification authority, and that Regent are working towards design basis agreement with them. And they have been in contact with Bureau Veritas. This is a French company specialized in testing, inspection and certification, founded in 1828 and well known to assist manufacturers to certify their vessels. So would the IMO accept the Viceroy as a ground effect boat? It is only limited in height by a computer system that could be overwritten or faulted. It is not a vessel that is bound to ground effect by its design outright. The Viceroy is essentially an airplane that is bound to ground effects by its control system rather than a skim machine incapable of flying outside ground effect. It will be fully capable of flying outside it if ordered to do so, making it an aircraft. In previous videos, we've discovered that the Viceroy geometry is unstable in ground effect. This has been confirmed by Billy Thalheimer in emails to us, and as such would be impossible to fly by a human. Regent are getting around this by having a computer control the craft. This means that the captain only inputs left, right, power, and the mode the craft needs to travel in: float, foil, or fly. This is all well and good. A computer control system would definitely take the strain off the captain, as constantly adjusting for height has been discovered by Russian Economoplan developers to be a major pain. Even James Greenberg, who flies as mudskipper in Australia, mentions the need for constant height input. And a modern airliner would also be computer controlled. However, it will be stable in flight. When the computer fails, it will be controllable by a pilot giving manual inputs if needed. There is also no hard surface nearby to crash into straight away. Of course, nowadays computer systems are reliable and they are made redundant. Some are even referring to the VTOL designs that are being readied to transport people. And sure, if for some reason the system fails for a Seaglider, the landing strip is always under it. Unfortunately though, if the captain cannot control the craft without the computer stabilizing it, it has a high chance to either crash right into the water, which at 300 km an hour would be unforgiving, or it would pop up like the Orion 20 did and crash land from a fair height onto that same unforgiving water surface. I think that's asking for trouble. I liken it to making a deep sea sub out of carbon fiber and then installing an acoustic system in there to warn you when it's failing. Now let's just talk about the elephant in the room. The box-tail section on the Viceroy, which is now evident from the full-scale mock-ups. The original renders still show on the Regent website the original high-tail configuration. A box wing, normally suggested for the main wing of aircraft, would be chosen to reduce induced drag. The Seaglider has it as a tail, so that it's less likely picked for the reason to reduce drag. At a guess, the function of the tail would be to avoid tail stall. In ground effect, the stall angle of a wing is lower. This means that a wing stalls or loses lift at a lower angle of attack. Once it does that, the wing sheds a turbulent wake behind it. With the original high tail of the Seaglider, if the wing stalls, it sheds turbulence over the tail and the lift of the tail will dissipate, and with it any control you have over the craft, whether it's computer controlled or not. In the case of the new renders, the top section of the box tail might be right behind the main wing if it stalls. The lower section could then avoid the stall wing turbulence. The added surface on the bottom of the box tail might help avoid a totally stalled tail section. What the box section tail also does, it adds directional stability, as you effectively have 3 vertical surfaces instead of just the one. Think of increasing the surface area of a weather vane. It turns out though, from a recent post on LinkedIn and a deleted post on Twitter from Oceanfly, that the main reason for the box tail is to actually reduce the weather vane effect during low speeds. At low speeds, the quarter scale test model must have had a tendency to put its nose into the wind, even though the captain would not have wanted to go that way. They explain rather awkwardly that the vertical tail surface exposed to the wind is less in a box tail arrangement. They mention the 2 horizontal tail surfaces as the reason for this, but they actually mean the fact that the main vertical surface has been divided up to 3 smaller surfaces, which reduces the area exposed to crosswinds. Observing the test flight video, there seems to be a crazy amount of negative lift from the tail. The horizontal tail surface seems to be angled upwards quite considerably, creating downwards force. The reason for this might be that it cancels out the moment that the waterfoil drag creates. An observation is that the test craft has got quite large flaps, probably to divert the prop wash down to create lift for the takeoff effort. This would also need a tail creating an opposite moment to counter this. Generally, a skim machine would have a positive lift in the tail to make sure it's stable in ground effect. A negative lift or a downwards lift in the tail is common in conventional aircraft. The angle of the tail surface comes down as soon as the hydrofoils come out of the water. This might indicate that indeed the tail cancels out the drag force moment of the waterfoils. Essentially all other skim machines that have had hydrofoils have used them solely to make the transition from boat to ground effect as easy as possible. But the Seaglider is deemed different, as it can foil as an extra mode of transport, and so is able to foil in the water for longer amounts of time. This is especially convenient in areas like harbour inlets, where low wakes are desirable. In the past, the X114, the predecessor of the Airfish 8, had hydrofoils attached to decrease the takeoff efforts. But it actually had the opposite effect, as it decreased the ram effect by lifting the craft out of the water, essentially leaking air from under the wing. It also were these hydrofoils that made the X114 crash as the hydrofoils dug into the water and pulled it down. The Viceroy will be equipped with retractable hydrofoils, but the same thing could be imagined to happen. From footage with a quarter scale model, the hydrofoils seem to be popping the craft up from the water when the speed is up to a certain number. This would be a result of trying to breach the hydrofoils out of the water as safely as possible. It doesn't look very comfortable from a passenger perspective, but it works for boats like the Sail GP yachts with its daggers. When a foil enters the water on landing, it would instantly add drag, which is like stepping on the brakes. If the foil comes out of the water for takeoff, the moment around the center of gravity changes dramatically the other way around, and the craft needs to adjust for it in the split second with the aerodynamic surfaces before it's too late and the craft flips over. The foils need to leave and enter the water at perfect angles. Even when computer controlled, this might be a challenge to do this consistently. The landing would probably be done with the foils retracted, as it would be dangerous to do with the foils out. But looking at the latest model, the foils would still enter the water before the hull does, even when they're retracted. First of all, there's an increase in the amount of motors from the original design. The original renders had 8 motors, but the new render has 10 motors. The props on these motors seem to be smaller in their new configuration. They might have decided that they needed more power based on the quarter scale tests, or a more distributed power over the wing, or an even more redundancy over the already 8 motors, which seems unlikely. We can see that the wing has got a drooping down of the wingtips, or what is called an anhedral. This is a difference between the first and the current render, but the quarter scale version already had this. It allows Regent to put floats on the tips of the wings for stability during floating, much like flying boats from yesteryear. It would also help build the ground effect more by keeping it high pressure air under the wing, keeping it from escaping from the tips. It would probably even help with keeping the craft stable in ground effect because of the stabilizing moment that is created. Then they have done away with the struts that were holding the wingtips down at the start. They always looked a bit strange, as at the start they were connected to the retractable hydrofoils and the whole wing seemed to move up when the hydrofoils were retracted. I'm assuming that these struts now are a thing of the past and they found a way to make these very thin wings stay in shape on their own. On the face of it, the Seaglider seems to be a logical, insane concept, but it's essentially an airplane that flies low. It has an unstable airframe and ground effect that is made stable with a computer system. Even with enough redundancy, I'm not sure if the IMO will fall for this. To certify an airplane as a boat just because it's limited to a certain height by a computer seemed to be a big risk. The foiling as an extra mode of transport between floating and flying is appealing for harbour work, and if we look at the foiling taking place in race boats, very doable. But as a passenger transport, it does add a very real risk. And again, just adding a computer control to it only paints over the problem. When we look at the numbers at the moment, it doesn't give an edge with regards to speed and range over existing planes. It certainly beats any boat by any measure, which is the whole point. These are very fast boats in the shape of an airplane, only without the costly maintenance and running costs of an airplane. I want to believe in the Seaglider, and the team that are behind it seem to be the first ones capable of actually getting skim machines into mainstream public transport. In the past, there have historically been two camps: the money-grabbing schemes that never made it past the drawing board, and there are still a few out there, or there were projects that were led by a technical team that were never able to market it properly. Regent seemed to have the best of both worlds, and they seized on the opportunity to sell the advantage of skim machines to start developing electric propulsion for. I just hope that Regent are approaching this very carefully, as one small accident with any of their prototypes or any of their production vehicles will not only set their own efforts back many years, but it will also be used as an excuse for ground effect boats to be shelved right next to the Hindenburg's airships, flying cars and jetpacks. For now, thank you very much for watching. Keep in the loop by hitting that subscribe button, and we'll see you here for the next episode of One Wingspan Above.